acids and bases, and unfortunately the last lesson of the year. In acids and bases, we've talked about definitions for acids and bases, properties of acids and bases, how to calculate pH, pOH, proton, hydroxide ion concentration, and the link to strong acids and bases. And that will be about as far as your quiz will go. Phone should not be out. We also talked about naming acids and bases and neutralization reactions last time. The neutralization reactions are going to come back right here. Today we're going to talk about titration, and with titration you can determine the concentration of a substance, in this case an acid or a base, or in some cases you can calculate the volume of an acid or base.
I know you've been asked this like a billion times, but we're going to get the pH, pOH formula things.
I'll give you all formulas for the quiz, the test, and a big formula sheet for the semester exam. All right.
You know the formulas on the quiz with like dots at H and stuff?
You want everything.
Everything.
Everything. Everything. All right. With titration, I've got a little video for you. I'll stop and start it because some of it is great and some of it needs some work. But in any event, this is a burette.
So long.
What goes in this long glass instrument, it's not a syringe, it's called titrant. This is called a stopcock. A stopcock. When the stopcock is parallel with the bench top, it is closed and nothing will drip through. When you turn it to the open position, everything will run through. Closed.
You were so good.
Burette.
You were so good.
What's it called again?
It's a stopcock. So, let's watch a little video that illustrates titration, and then I'll illustrate it for you live during our next class. So what is this long glass? You didn't listen to the question, silly goose. Burette. Burette is in French, like chapeau, beret. This is a burette. It's masculine versus feminine endings, and that's masculine. It has the stopcock.
Please post this video.
It's a stopcock. What's wrong with that?
So Devin, what's this called?
Stopcock.
You got it.
It's a scientific term.
Who made that word up?
Yeah.
This will be like our little yearbook.
Alright, in badminton, the ball is called a shuttlecock.
I want to hear them say stop.
is used to slow up the class, while the left hand controls the stop clock. Stop clock is a found pointer and middle finger. This allows better control for delivering partial drops. Check to see if the burette is clean by rinsing with water and noting any beads on the walls. Make sure the stop clock is closed. Bring the burette down below eye level. Use a funnel to add small portions of titrant for rinsing.
So the titrant goes in the burette.
Wet all areas of the burette with your titrant by rotating horizontally and drain out through the stopcock. Drain all rinses completely. Repeat this 3 times to ensure all contaminants are out.
Typically, when you prepare the burette, you rinse it twice with distilled water and then 2 times with titrant. So if you're putting 1 molar sodium hydroxide into the burette, you'd rinse it twice with distilled water and twice with the 1 molar sodium hydroxide.
Fill the burette above the 0 mark with your titrant. Pour with the burette below eye level.
And now
Pour
she's
slowly
preparing
so the
it.
burette does not overflow. Remove the funnel after filling. Check for bubbles in the burette, especially in the tip. Bubbles will cause significant errors in volume. To remove any bubbles, quickly move the stopcock back and forth. Move the burette 0 mark to eye level to avoid parallax, and bring it slowly to the 0 mark or below. Remove any hanging drops from the tip of the burette by touching it to a clean glass surface. Any drops are considered delivered volume. Record the initial volume by using a card with a dark line. This helps darken the meniscus for better reading.
And I do want to indicate this is an error in the video. You can see the graduations here, and you can read to the 10th place. So you know in terms of sig figs, then you have to record to the 100th place. The last digit's uncertain. This was a big mess on an AP exam one year. This digit here is either a 0 or a 5, so be careful. This is an error. You would report this at 1.15 mils. This last digit you're guesstimating, you're going to guesstimate at a 0 or a 5. And I agree there. So then you have to decide, should you report it, you know, as 1.15 or 1.20. It's not a perfect science.
Would it be like 7.5, which rounds to 8, and it's like in between? Okay.
I don't think you have to get that technical with it. Although in ACE chemistry, which we don't offer here, there's a laboratory component to the exam. And one of the questions one year was in terms of titration, and you had to do the titration and calculate the concentration. And if you were off by, I believe it was 0.05 molar, it was incorrect. So that, you know, an error there or bubbles in the burette can greatly affect your results.
To 2 decimal places. Add 2 to 3 drops of indicator to your analyte. It is wise to do a rough titration to determine the relative volume needed to reach.
So she just added phenolphthalein, which is an indicator to acid, and you can see there's no color change. That's how I know she added it to acid, because if you add phenolphthalein to base, the solution turns pink, which is what you're going to see.
See end point. Place the flask under the burette on a white background.
So what's in the Erlenmeyer flask is the analyte. What's in the burette is the titrant.
The color change will be more noticeable. Adjust the burette so the tip is inside your flask to avoid loss of titrant. Add the titrant rapidly and first.
Now what you're seeing here are pockets of pink, and that's because what's happening here is you're adding the base to the acid, and you've added the base to a small region that's neutralizing the acid but not neutralizing all the acid. So it's really important when you titrate that you continuously swirl throughout so that you're getting all the base you're adding to react with all the acid that's in the flask.
With constant swirling. As the endpoint approaches, the color will be more persistent. Slowly drops down to 1 per second.
Whoa.
Right, because you haven't gotten all of it to react. You haven't neutralized all of it.
Sides of the flask and wash
How's
the
it like-
sides down with
it's like
water
appearing
so that
and
all titrant that has been delivered has reacted.
So what's happening there is you haven't neutralized all of the acid in the flask. You haven't added enough base to neutralize all of it. When you've added enough base to neutralize all the acid, you're going to see a faint pink color that remains. Then you've got the end point, that pink color, and at the equivalence point, the millimoles of acid and base will be stoichiometrically equivalent, and I'll point that out on paper in a minute.
Slowly open the stop trunk and allow a partial drop to form. A partial drop just covers the tip of the burette. Touch the tip and rinse until the endpoint is reached. The endpoint is noted by a faint color that is persistent for at least 10 seconds, but not permanent. Obtain a final reading.
And again,
The volume
10.20
titrated is the
or
difference between the
10.25.
initial and final reading.
I would have gone
The concentration
10.25.
under NO can now be calculated. Let's review the steps.
All right, and so that's how you perform a titration, and I'll illustrate that for you in the lab next week so that you get a good feel for it. And that link is in your notes in the event that you want to go back and review the video. All right, so some of the terminology that she used I've put in your notes. Again, with titration, you're going to gradually add one reactant from the burette, that's the titrant, to another reactant that's in the flask, that's the analyte, until you get a color change. The color change is the end point. So what you're seeing is the end point. You're seeing a color change. It signals the equivalence point, where you have equivalent amounts of moles of reactants, in this case acid and base. If, for example, you had hydrochloric acid reacting with sodium hydroxide, remember an Arrhenius acid and an Arrhenius base generate salt and water. When you have just enough base to neutralize the acid, you're at the equivalence point, and the moles of acid and base are equivalent. You'll see the end point, you'll see that color change. Before the equivalence point, what you saw is you didn't get all the acid to react with the base that was added, so you've got a colorless solution. At the equivalence point, that's when you get that faint pink, and if you kept dumping base in there, it would get darker and darker pink. And what we want to make sure we can do is calculate either the concentration or the volume of an acid or a base. It's a 4-step process. I'm going to walk you through these 4 steps. I'll label them as we go so that you can follow through when you review these concepts later on. But when we work through 3 practice problems, I think you'll feel very comfortable with this type of analysis. It's not difficult. It, like everything else in chemistry this year, requires practice. In the first step, you're going to write the balanced chemical equation and you'll record the information provided. These will be neutralization reactions that we learned how to write last time. And if you missed anything in this acid-base chapter, all of the lessons are posted. It may or may not be your class period, but everything is posted. Next, you're going to calculate moles or millimoles of the acid or base, and you'll do it for the one that you know both the concentration and the volume of the substance of. We learned previously, Maddie, can you flip the light switches? I didn't do it right. So the green versus the red tape, just flip them. Thank you. All right. So we know that molarity is a unit for concentration, and we know that molarity is moles of solute over the volume of solution in liters. Because in titration, the volumes will be in milliliters, we're going to use millimoles. We know that 1 mole is 1,000 or 10 to the 3rd millimoles. And to calculate millimoles then, we're going to multiply the molarity times the volume in mils. This is much easier because you don't have to convert from mils to liters, etc. So in step B, we'll calculate the millimoles of the acid or base, what we have both the concentration and volume of. Next, we're going to calculate the millimoles of the other substance using stoichiometry. And again, one really nice thing about this chapter is it reviews stoichiometry, it reviews some information or concepts that we learned in the solution chapter. It also goes into balancing equations, predicting products, etc. So a lot of concepts that we talked about earlier this semester. Once you have millimoles of the other substance, you'll simply divide it by the volume to calculate the concentration, or divide it by the concentration to calculate the volume. I'll point that step out in more detail when we get to it. So it's a 4-step process. We're going to walk through the first example piece by piece as well as the second, and you'll try to walk me through as we get more comfortable with this type of analysis. In this problem, it says a titration of a sample of 20 mils of hydrochloric acid. 30 mils of 0.2 molar sodium hydroxide is required for neutralization. Calculate the concentration of the acid at the equivalence point. One thing you have to be able to do is write chemical formulas for acids and bases as we discussed the other day. In step 1, you're going to write the neutralization reaction. So step A, we're going to write hydrochloric acid reacts with sodium hydroxide, and I usually do acid plus base, doesn't matter though. We know an Arrhenius acid reacts with an Arrhenius base to generate a salt and water. And that equation's already balanced, making it really much easier because you have a 1-to-1 mole ratio of reactants. What I also like to do is write down the information. I want to figure out the concentration of the acid. That's the goal. I know the volume of the acid is 20 mils. The concentration of sodium hydroxide is 0.2 molar. The volume of it is 30 mils. So that's step A. In step B, we want to calculate the millimoles of the substance. We know both the concentration and the volume of. So what are we going to figure out millimoles of? Got to be the base because we have both the concentration and the volume. So we have 0.200 molar times 30 mils. That's 2 times 3 is 6 millimoles of base. So whatever we know both the concentration and the volume of, we will get the millimoles of that substance. In the third step, using stoichiometry, we're going to convert from millimoles of base to millimoles of acid. And this is a 1-to-1 mole ratio. Instead of moles, we're going to use millimoles. So we have 6 millimoles of acid. And then finally, to get the concentration of the acid, concentration, unit of molarity is millimoles of that acid divided by the volume of the acid that we were given initially. And that's the beauty of writing everything down. It's all there for you, and it's easy to find that information. That's 6/20 or 3/10, so that's going to be 0.300 molar concentration for HCl. So it's a 4-step process, and if you're very careful in regard to indicating those steps, you don't have to label A through D, but if you work through these 4 steps very carefully, I think you'll be extremely successful with these types of problems. Questions on the first example? Pretty straightforward? Yes, we can do this? Sebastian, yes? Super. All right, in the second problem, we've got a sample of 1.5 molar calcium hydroxide. Devin, is that the acid or the base?
The acid.
It's got to be the base, hydroxide, right? Yeah. 25 mils of 0.8 molar hydrobromic acid. That could be the acid, huh? We want to calculate the volume of the base at the equivalence point. All right, our acid is hydrobromic acid. How do we write the chemical formula for hydrobromic acid? Josh. Why is it HBr? Because it starts with hydro. And hydro is always binary.
Right.
All right? And if you're having trouble remembering, think hydrochloric acid, you know, is what? HCl. And that's going to signal you in. So it's okay to make mistakes now. It's good to make mistakes now because you won't make them when it really counts. Hydrobromic acid reacts with calcium hydroxide. And watch your formula writing here as well. Don't forget those parentheses. If you can't get an equation to balance, go back and check your formula writing. You can't see anything. Oops. I'll let you get that down. What are always the products of a reaction between an Arrhenius acid and an Arrhenius base? Salt and water. So the water's easy. What salt do you generate?
Calcium bromide.
You got it.
Yesterday we had like an equation that was at equilibrium.
It was neutralization. This is a neutralization reaction. It's the same type of reaction.
Okay.
Equilibrium would have the double arrow.
Right. So like, does that make a difference if it's at equilibrium and how we solve?
At a higher level of chemistry, it would. For here, we're going to keep it simple. If you have a strong acid, strong base, it's just going to go forward. Strong acid, strong base, it'll just go forward. It's a good question. All right. We also want to get the information down. The concentration of the base is 1.50 molar. We do have to balance. The concentration of the acid is 0.8 molar. The volume of the acid is 25 mils. And if you don't balance, you're also going to have issues. So balance off.
Wait, when was it acid?
Say what?
The concentration of the acid?
0.800 molar. We're going to get millimoles of which substance first? Why will we get it for the hydrobromic acid?
Because you have both the variables.
You got it. You have both the concentration and the volume. Should be 20, right? And that's going to be 20 millimoles of hydrobromic acid. And we're going to use that to get millimoles of the base. And this is where if you don't balance the equation, your stoichiometry is going to be wrong. So we'll divide by 2 and we have 10 millimoles of base. Now this problem's a little bit different because we're asked for the volume of the base. And let me make sure you're where I'm at and I'll walk you through how to do that. Okay, so previously when we were finding concentration, we divided millimoles by the volume. That's what you're more familiar with. But clearly, you could calculate the volume because we've talked about several times this year where you can interchange the denominator on one side of the equation with the numerator on the other side of the equation. So if you want to calculate the volume, you can do millimoles over the concentration. And I'll point the units out here so it's clear to you. You have 10 millimoles of the base. We're going to divide that by the concentration of base, which is millimoles over mils. So the millimoles will cancel. Mils is in the denominator of a denominator, which flips it to the numerator, and you have 10 divided by 1.5 is 6.67 mils of base. Typically they ask you concentration, but I tried to give you a couple different types of problems. Say it again?
It says that there's a sample of 1.5 moles of calcium hydroxide. Why do you have millimoles on the bottom?
So molarity is moles over liters, or we said earlier it can be millimoles over mils. So I did it this way so I could show you how these units cancel. And then if you have 1 over mils, that's going to be the same thing as 1 times mil over 1, so that's mils. That's how you get that unit. It's like 1 over 1/3 is 3. Yeah. All right? And I have one more problem I'd like to walk through with you. This one, at least for the neutralization reaction, is much trickier than anything I'd give you but there's some relevant chemistry here in household objects, so I really think it is a good example. In this last example, it says in a titration of a sample of vinegar, 11.10 mils of 0.748 molar strontium hydroxide, acid or base, Devin? Base, is required to neutralize 10 mils of vinegar, acid. It turns out that vinegar is 5% acetic acid. So we can calculate the concentration of the acid in the vinegar using a neutralization reaction. In addition here, you'll see that it says calculate the theoretical yield of the salt that forms as well as the actual yield when given percent yield. These two questions relate back to stoichiometry, and I'm going to walk through them with you even though we've done this type of question earlier in the year, but it's been a while. So I want to make sure you're comfortable with this because you do have several practice problems on your classwork, and you'll see a test question very much like this with a simpler equation. So let's walk through this one very carefully so you feel comfortable with this type of analysis. The equation is going to appear a little bit odd. I won't give you acetic acid on your test in a titration. You've got acetic acid reacting with strontium hydroxide. You're going to generate strontium acetate and water. And again, the ionizable proton for acetic acid is the H that's part of the Cu group. This one's a little harder than anything I give you. Typically we do 2 titration labs. One is with acetic acid, so I just wanted to give you an example. The concentration of the base that's given is 0.748 molar. The volume of the base is 11.10 mils. The volume of the acid is 10 mils. The concentration of the acetic acid is what we're looking for. So we've covered step A. What do we do next? We're going to get millimoles of the base by multiplying the concentration times the volume. And that's 8.30 millimoles of base. What do we do next? Huh? Mole ratio, because we want to get millimoles of the acid. So we have 1 millimole of the base, 2 millimoles of the acid. And then our goal is to get the concentration of the acetic acid. We've got the millimoles of it, and we're going to divide by what? The volume. Good. And that's the concentration of the acid. Now that's the titration piece. The other two questions I want to make sure you're comfortable with. One year I assumed that the kids had remembered, and then it was very clear that they didn't. So I think it's wise to walk through the problem very carefully, and I can do more of these if needed. The next question says calculate the theoretical yield of the salt that forms. So we're looking for the mass of strontium acetate in grams. To calculate the mass of the strontium acetate, keep in mind theoretical yield. The yield has to be a product. Products get yielded. The millimoles of the base and the acid are stoichiometrically equivalent. So you can start with whichever one you want. I'd start with what I initially calculated in case I made a mistake here. So from the millimoles of the base, I can, in a series of steps, get to the mass of the salt. And again, it doesn't matter if you start with the acid or the base. I know that 1 mole is equal to 10 to the third millimoles. So if I'm going from millimoles to moles, I divide by 1,000. So that means I have 8.30 times 10 to the negative third moles of base. I divided by 1,000. Or multiplied by 10 to the negative 3. You're going up the scale, make sure the number is getting smaller. From the balanced equation, I have 1 mole of strontium hydroxide to 1 mole of strontium acetate. For every 1 mole of strontium acetate, I can get the mass in grams from the periodic table. And that makes 1.71 grams of salt. So that's just pure stoichiometry that you learned back at the beginning of the third 9 weeks. Again, you can start with the moles of the acid or the base. It doesn't matter which one, they're stoichiometrically equivalent. The rest of it is just baby stoichiometry that you have learned previously. The last question of this set is also review. It says that the percent yield is 80. We want to know the actual yield. Now let's think back. Percent yield is equal to what? That's percent error. It's at A over T. So its actual yield This is good review, not only for your test, but also for your semester exam. You're going to see a lot of stoic. It's actual yield over theoretical yield times 100. So if I'm solving for the actual yield, then that's going to be the percent yield over 100 times the theoretical yield. Theoretical yield I got in the previous problem. The actual yield over 100 is 0.8 times the theoretical yield, and 0.8 times 1.71 is 1.37 grams for the actual yield. That's how much he generated in the laboratory. All right. Now these pieces are review. You know how to do them already. It looks from some of your faces like you need some review there, and we can get that review. If this looks very foreign to you, you will want to review quiz 3.2. That's where this concept was assessed from stoichiometry. So your goal is to understand titration, how to calculate the concentration of an acid or a base based on titration data. You want to be able to link this to theoretical yield as well as percent yield. And if you can do that, you'll be very successful on that component on the test. What's also in your notes, we've actually covered already. I just indicated it again as review. We've already talked about the fact that strong acids and bases ionize completely. And this was a little bit with your question, Maddie. So strong acids and bases ionize completely. The concentration of acid and proton or hydronium ion is the same. Weak acids like acetic acid don't ionize completely. You've got an equilibrium reaction, and the concentration of acid and hydronium ion or proton is not the same. That's more for AP or advanced chemistry. We talked about strong bases as well. We talked about the binary acids as well as the ternary and the polyprotic acids. So this just summarizes what we've already talked about. In regard to Ka, Kb, and Kw, I'm not going to get into this at the honors level. I think it's very complicated. For those of you who want to go through it, I'm more than happy to go through it with you. I also want to make it crystal clear what's on your quiz, what you need to work on now, etc. So, in regard to what's on your quiz, this goes up till the naming. So in regard to your quiz, from your classwork, that's 1 through 21. The other day I had told you you should do 22 through, I believe, 28. What we talked about today is 29 through 31. But this is the piece for your quiz. Also on the test is the naming. Actually, that should be 4.4a. And what we talked about today would be 4.4a, page 2. So this is what goes with today's lesson. And I don't know if you'll finish all of the classwork in the next 40 plus minutes, which we have, But if you've kept up with your classwork, you should be able to finish it all, leaving you with no homework over the weekend. Monday is graduation. Unless your mom or dad really wants you to come to school, it probably would be better spent at home, unless you're going to graduation for a family member, friend, band, etc. But you have the remainder of the period to work on your classwork. Any questions about anything we've talked about today?